All right, so I jumped in here to our last real slide here, and this is a kind of the design discussion. And some of you already kind of asked this question or we're talking about it in chat. And I want to start off here. This is really the first time as network engineers where we're faced with an overlapping design technology situation. So what I mean here is we have spanning tree on one hand, and we have FHRP, whatever flavor, on the other hand. And let's assume here it's HSRP for this example again. Like, this is all about design, right? We could effectively design STP in a vacuum, and then we could effectively design HSRP in a vacuum, and we could forget about them interacting. But if we do that, it's a design failure. There's potential design failures there. So we have to actually design both those technologies together. And that whole use case there is going to live throughout all design moving forward. You're going to realize that we can design individual protocols on their own, but then we also really need to design protocols with other protocols in mind. There's other overlapping protocols that we have to design together. And that's what I want to emphasize here. So we have a spanning tree, we have HSRP. So for this example, we have our VLAN 22 host, the green host, and he's still connected to the access switch. We have our root bridge is VLAN, for VLAN 22 is on distribution switch 1. But in this case, our HSRP group that's active is on distribution switch 2. So, you know, we designed both protocols and we designed them effectively individually. But for whatever reason, we said that DSW2, our distribution switch 2, will be the default gateway, the active default gateway. And then DSW1, distribution switch 1, will be our active root bridge for VLAN 22. So as we go through this, I'm going to ask questions how this traffic flow is going to look. So first, our host traffic is going to go to the access switch. So at this point, what's going to happen, right? Is the traffic going to go to distribution switch 1, or is it going to go to distribution switch 2? So I got William saying it's going to go to 2. I got Peter saying it's going to go to 1. I got William saying it's going to be a Z shape. I got someone else saying it's going to go to distribution switch 2. All right, so what's happening here is distribution switch 1 is the root bridge, right? And if we actually followed how all the ports are going to go from forwarding to designated to alternating to blocking, this port right here is actually going to be in the blocking state, the non-forwarding state. All right, so traffic is not going to go from access switch to distribution switch directly. It's actually going to go to distribution switch 1 because of that state. Because again, that is the root bridge for VLAN 22. All right, hopefully that's clear. I'm trying to make it clear as mud or clear as water, whatever works. At this point, where is the traffic going to go? Is it going to go from distribution switch 1 to the internet, or is it going to go from distribution switch 1 to distribution switch 2? What's everyone think? I got Kevin saying 2. I got Peter saying 1 to 2. I got someone else saying switch 1 to switch 2, 1 then to 2, and that's accurate, right? So it's going to go from switch 1 to switch 2. Does anyone know why? Default gateway, first STP, gateway is on 2, the gateway is there because the gateway, yes, you guys are correct, right? And specifically from a technology perspective, it's because of the MAC address lives on DSW2. That active MAC address for that default gateway is on DSW2. It is not on DSW1. So now we have to send that traffic across those two switches, and then finally that traffic can go to the internet. Now, do you see the implication here on why this is a problem? Do you see that we're not using this link, right? So we add an extra hop here. And then in addition, we add another extra hop going across that kind of core link or that distribution link back to switch 2 and then out to the internet. Suboptimal routing, right? This is a suboptimal design. And in some cases, this is actually a design failure. Design failure. All right, I went through all the things I want to talk about on this. Mohammed, is there anything I missed or anything you want to add?
No, brilliant. You nailed it, Zig. This is remind me, remember, there's a very good book by Russ White and Jason Sura, which is called Network Complexity and Complexity Systems. And they are talking about even for normal engineering, if you have like multiple systems and each system by itself is complex. When you integrate or have like a connection between these two systems, you have to be smart, the nodes between the systems. So here we have like layer 2, which is the MAC address, the spanning tree, and top of it we have like layer 3 and HSRP. So don't add to the complexity. So design it well. So you have to make like the interaction between the two, the smooth it, and maybe design it better so they can work hand in hand. Instead of layer 2 is working in its way and its word and its way, and layer 3 is working maybe following the opposite way. One is clockwise and the other one is anti-clockwise. So it would be better if you design your system that these two layers complete each other. So something just to keep in mind that usually the engineering mentality, the design, and always try to keep the solution determined and controlled and simple. All these add together to make it a better solution. This is my last word here. Back to you if you have additional comments.
Thanks, Mohammed. So I just quickly drew a blue line on the preferred traffic flow, right? So that's the preferred traffic flow in this situation. I didn't actually add it on the slide in animation, but I wanted to make it clear that that's what it should have been from a design perspective. The green line is what it actually is because it was designed incorrectly, right? Any questions, any comments, any concerns? I'm going to go to the next slide. Thank you. That's where we're at. We're at a wrap. I mean, we made it to 6:30 in the morning, U.S. time. I don't remember what time it is everywhere else. And I would say thank you all for joining us today. Let us know like how this was, if you liked it, if you enjoyed it, if you want more of it. I mean, whatever you want to put out there, let us know on LinkedIn, Twitter. Join the Discord server. Talk to us live, right? Mohammed and I are in there, again, at zigbits.tech/discord. I'm in there all day. If you want to ask me questions, have a design conversation, we can even do a video call, a voice call. Just feel free to reach out anytime. And with that, I'm going to leave it over to Mohammed to close us out.
Thank you, Zig, and thank you everyone to come in your busy days. I mean, some of you still during the working day, and it was great. And I believe it was a great initiative from Zig and myself to have this session. And as I mentioned, if you really like it, maybe comment, send us your preference for the next one. Shall we go, as example, for AIGRP, OSPF, ISIS, or whatever? Choose the next topic, and let's keep talking on Discord, LinkedIn, Twitter. We are available on all these social media. Thank you again, and looking forward to the next one.
Awesome. Hey, guys, have a great day. Thank you so much.
Thank you.
And take care and enjoy the weekend.
Thank you.
The rest of the week.
Yeah, thank you.
Thank you.